All right, so lesson 3, and you know what? On my copy, this is Unit 3, Lesson 3. That's Unit 2, Lesson 3. So what we're going to focus specifically on logarithms today, or in this lesson. And logarithms are interesting in that you can add and subtract logarithms, but they have their own little rules. So I think you'll find that these are kind of interesting. So let's say you have two logarithms, log base a of m, and you want to add log base a of n. Well, first of all, let me just say, in order to add logarithms, they have to have the same base. All right, adding logarithms doesn't actually involve addition. It involves multiplication. So to add log base a of m with log base a of n, you keep your log base a and you multiply m and n. So log base a of m plus log base a of n equals log base a of m n, the product. When we talk about the difference of logarithms, let's say you have two logarithms that need to be subtracted. If they have the same base, then the operation that is involved with logarithms and subtracting is division. You keep your log base a, but you divide m by n. So whatever you're subtracting is the expression that goes in the denominator. So addition and subtraction actually involve multiplication and division. So now let's talk about the coefficients of logarithms. Let's say we have a logarithm that has a coefficient, let's say r. So if we have r times log base a of m, that coefficient can become the exponent of the expression m. So when a logarithm has a coefficient of r, you can rewrite it as the exponent of the expression m. You don't flip it, you don't change the signs, you just move it. And that is a property of logarithms that we will actually use quite a bit later. All right, then the next thing we have is what if the coefficient is negative? So if we have, let's say, negative, or the opposite of log base a of n, that actually turns out to be log base a of 1 over n. If we treat the negative, let's see how we end up with 1 over n. If we treat the negative as negative 1, when you have negative log base a of n, the negative 1 becomes the power of n, so that's n to the negative 1. And what's another way to write n to the negative 1 but 1 over n? So that's how, or that's why the opposite of log base a of n is equal to log base a of 1 over n. Okay? So here's what I want us to do. I just want us to get practice working with the properties of logarithms. The first set that we're going to do is we're going to take 6 different expressions and we're going to express them as a single logarithm. In other words, on example 1, we're going to add these 2 logarithms. On example 2, we're going to add these 2 logarithms, and so on. So the first set, that's what we're going to do. So the property of adding logarithms is, since they have the same base, we will keep the log base 6 and multiply 2x times 5, and that gives us 10x. So pretty simple. This second example, we have a log base 3 of x, and we want to add log base 3 of x plus 1. So we're adding 2 logarithms that do have the same base. So we'll keep the log base 3, and we will multiply the x by x plus 1. So there we have our expression, and we could, if we wanted to, we could rewrite it as log base 3 of x squared plus x, but that would have to be in parentheses though, okay? So either one of these is perfectly fine. All right, now let's talk about the opposite of log base a of x plus log base a of 9. So notice that this first logarithm has a coefficient of -1. Well, we need to remember that that logarithm can be written as log base a of 1 over x, but I'm going to put this intermediate step in there of x to the -1. Then we want to add log base a of 9. So log base a of x to the -1, we can write it as log base a of 1 over x plus log base a of 9. And now we can take care of the addition, and we get log base a, we multiply 1 over x with 9, and so that gives us 9 over x. So there's our expression. Okay? All right, now our next one, we have example 4, and this is not a coefficient, that's just the number of the example. We have log base 6 of x squared minus 1 minus log base 6 of x minus 1. So here we have a subtraction problem. So we're going to rewrite this. My little buddy, you're going to have to leave. Where'd you go? So I know you want to be a part of this, but I've had enough of you. Okay, sorry about that. Had to get rid of little buddy there. So we're subtracting. So that means division. So I'm going to keep the log base 6. I will take the x squared minus 1 and divide it by x minus 1. So here we have log base 6 of x squared minus 1 over x minus 1. And hopefully you recognize that numerator as a difference of squares, and differences of squares will factor. So log base 6 of x plus 1 times x minus 1 over x minus 1, and the x minus 1's will cancel, and that ultimately reduces down to log base 6 of x plus 1. So we factored here and we canceled. So the higher the level of math course that you are in and taking, the more previous math that you use. All right, so let's take a look at the next one. Ooh, okay, this one's got a lot. We've got log base a of x. We've got plus log base a of 9, plus log base a of this x squared plus 1, and then minus log base a of 5. Okay, so I do not have any coefficients, no coefficients here. Well, let me rephrase that. This coefficient is 1, this coefficient is 1, this coefficient is 1, this coefficient is -1, but I'm going to treat that as subtraction. So, excuse me, going left to right, I've got these three added together, which means I can add them, they have the same base of a, and I can multiply x times 9. I'm going to write that as 9x times x squared plus 1 minus log base a of 5. Okay. Then I'll take care of the subtraction, and we have log base a of 9x times x squared plus 1 over 5. Yeah, and there's your single logarithm. All right, now let's take a look at our next one. This is the last one that I want us to do, where we're going to write this expanded version of a logarithm down to a single logarithm. Okay, this term has a coefficient of 3. This term has a coefficient of 1/2. This term has a coefficient of, you can either look at it as a -4 or just treat the coefficient as 4 and keep it subtraction. If you treat this coefficient as -4, then you're going to take and change this operation to addition. Okay. I want to rewrite log base a of x as log base a of x to the third. Remember, you don't flip the coefficient, you don't change the sign. The coefficient simply becomes the exponent of the x, the variable, or whatever's right here. Same thing with the 1/2. I will now have plus log base a, and this is going to be x squared minus 4. We will raise it to the 1/2 power, and then minus the 4 is going to become that coefficient of 4 log base a of x plus 1 to the 4th power. So this example has several coefficients that we needed to write as powers. Now I will go from left to right, and I will take care of the addition, which will be log base a of x to the third times x squared minus 4 to the 1/2. And I'm going to go ahead and take care of the subtraction. That involves division, so it'll be x cubed times x squared minus 4 to the 1/2 over x plus 1 to the 4th. And there is your single logarithm. Okay? All right. So now let's do the reverse. So here we have log of 12 x to the 5th y to the -2. So what we're going to do is we're going to take this expression and write it in an expanded form. So let's take a look at what we've got. We've got this 12 x to the 5th, y to the -2. I noticed that 2 is multiplied by x to the 5th, which is multiplied by y to the -2. So how do we separate or expand multiplication? That involves addition. So we will have log of 12 plus log of x to the 5th plus log of y to the -2. Now, if you'll notice, I did not include a base, which is fine. The base is understood to be 10. Nothing wrong with that. Now, there's one more thing. In expanded form, you do not want powers. So expanding logarithms okay, let me try that again. When you expand a logarithm, you want coefficients, not powers. So this remains log of 12 plus the power of 5 becomes the coefficient of the log. So 5 log x, and the power of -2 becomes the coefficient of log of y. Now, the -2, when it comes out front, this we have as plus. That will become minus 2 log of y. And there is your expanded version of that logarithm. Many times it's easy to put things together, but taking them apart, breaking them apart, is where the challenge is. All right, now our next example, number 8. So I have this log. Notice that I did not include a base, so it's understood to be 10. I have this right here, the division of x squared and square root of 4x plus 1. So let's take care of the division part first. This is going to give me log of x squared minus log of the square root of 4x plus 1. I had to think about that a minute. To undo the division of a logarithm, that will involve subtraction. So log of x squared minus log of the square root of 4x plus 1. Okay, so I want you to look at the square root. Expanded versions we don't want square roots. We don't want radicals. So what we have to do is we need to remember that radicals can be written as a power. So what that would be log of x squared minus the log of, remember the square root can be written as 4x plus 1 to the 1/2 power. And like the last example, we do not want expanded form to have